Hello and welcome back. It's In Code We Trust, and today we're going to do another LeetCode 347 top K frequent elements question from Blind75 list. And apart from being a Blind75 question, this problem has been identified as an Amazon interview question. So if you are interested in applying to Amazon, definitely check it out. For those of you who are not familiar with Blind75, it's actually a list of top 75 LeetCode questions that has been curated by Tech Lead from Facebook. And in my opinion, this list contains very high quality problems that supposedly cover every single aspect a candidate can face during the coding interview at big tech company. So if you are applying, definitely check it out. I'll have a link in the description below. But also I have this spreadsheet where I track every single problem. I have the notes for every problem, and the idea is that I want to create a video on every single problem. And even for some problems, as you can see, I'll have more than one video where I show all the different ways you can tackle the problem. So definitely check it out. I'll have a link in the description for it as well. So let's go back to the questions. And okay, another side note here is for those of you who wonder why am I doing it in a Google document settings and not just solving a problem in a LeetCode, I have a separate video. If you haven't watched it already, please, I'll have a link somewhere on the screen right now, but definitely check it out where I'll go into in details why it is beneficial to at least practice solving questions in a Google document settings. And I have a framework that I'm going to use in this video as well, but like I'll explain in a framework why every step of a framework is important and like what is the framework is actually. So if you haven't watched it, watch it right now. You can pause this video. So we are given an integer array nums and an integer k. So and we want to return zk most frequent elements. So remember the framework, guys. What you want to do here is first start by asking the right questions. What you don't want to do is just jump straight to the coding part and assume something, especially if you have seen problem like this. You can see clearly, like here we have a lot less information that, for example, the actual LeetCode question gives us. Like, for example, we don't have examples, we don't have constraints. So all of that is done on purpose, actually, to mimic what your actual interview might look like. So we definitely don't want to make any assumptions, and we want to start by asking the right questions. Actually, let's try to come up with some inputs, example of inputs, so it would be easier to ask those questions. We can say that, okay, if I understood you correctly, let's get an example of what array nums might look like. So we can say, okay, we need to have some duplicates in an array in order for them to have frequencies. So let's say we have 1, 1, 2, 2, and let's say we have 3, 3. It's a pretty like an easy example anyone can come up with. So it should do the work though. Let's say n k is equal to, I don't know, 1 or 2, it doesn't really matter. But this example already creates some problems or clarifies that we have insufficient information. So you can see here, like every element of this array is duplicated at least at least one. So 1 has frequency of 2, 2 has frequency of 2, and 3 has frequency of 2. So, and we need to return 2 most frequent elements. But since they all like have same frequencies, what should we return? It can be any combination of numbers like 1 or 2, or 2 and 3, or 1 and 3. You can see where I'm going here, right? So the valid question is how to resolve those ties. Can we assume they're not going to be any ties like this? Or just like asking that question clearly shows your interviewers that first, like your seniority level, and that you understand the question, and you have like a deep understanding of the question, and you're thinking about edge cases and stuff like that. So that definitely check some boxes in your evaluation sheet. That's why it's very important to ask those questions. Start by asking questions, right? So imagine your interviewer goes ahead and says, oh no, actually you can actually assume that k most frequent elements are going to be like unique, and you don't have any ties, like you don't have any choices for which elements you need to choose for those k most frequent elements. So with that being clarified, we can move on. Another question that we can come up with is actually what's going to have, like thinking about edge cases. Let's say this k is 100. What should we do then? Can we assume that k is going to, we need some like constraints on k. K actually can be only at most 3, right? That's like number of unique elements in an array nums. So like just agreeing on that. Saying that, okay, I can see there might be a problem in case when k is greater than the number of unique elements in our array. Clearly is a bonus point for you and will help you solve the problem. All right, so now most importantly, we have demonstrated to our interview that we clearly have understood the problem. Let's move on to the next part. Next part is outlining our solution. All right. So actually, before we jump into that part, let's agree with our interviewer on the output, like how should it look like. In this case, I think the output can be an array, and we just need to return the top k frequent elements. And for this example, and actually, like this is exactly why this step is very important, because now we have a question for this particular array. We can clearly see that the top two elements are 3 and 2, but the question is, does the order matter? Like, do we need to return 2 and 3 things like 2 comes first, or do we need to return 3 and 2 because 3 has a frequency of 4 and 2 has only frequency of 3? Right, so this is definitely a question you need to clarify with your interviewer, because it's definitely going to affect your overall solution. So with that being said, I think in this case, it doesn't really matter. I mean, the question prompt says on LeetCode that we can return the result in any order, and we can just quickly specify any order of result. It's kind of important to put those small notes, because that's like something you have agreed on, and in the future you can always reference to this, and sometimes people forget. So, and maybe like if you're doing your interview doing Zoom, the connection is not very stable, and like you can mishear something and stuff like this. So putting a little note is always a good idea. So all right, with that being said, let's outline a solution. Questions like this, where you have to deal with like k most frequent or like k most least frequent, k I don't know, like from any sort of array or like data structure pool of elements, you have to extract or get some most or least some sort of a sub array of the collection, and you have to do it by some property. In this case, it's the frequencies. In those cases, it's always a good idea to start thinking about heaps, and there's also an algorithm called QuickSelect. This is the one we're going to use for this video, but I believe I quickly mention, just want to quickly mention that this question can be also solved by bucket sort technique. Yeah, and I think I will have separate videos for every single approach, but yes, so you can like if you know this stuff, you can definitely mention that there are several approaches you can like take to tackle this problem, and you can quickly like mention pros and cons of each one, and ask your interviewer which one he or she prefers you to implement, right? So with that being said, let's dive into the outline of the approach. So so the first things first, we need to construct like our dictionary where we're going to hold, like we're going to go through this numbers array and construct a new data structure that's going to say like element 1 is has a frequency of 2, and element 2 has a frequency of 3, element 3 has a frequency of 4, and so on. So the way we can do it is construct a dictionary, and the key is going to be the actual number, and the value is going to be the number of times it is present in that array. So we can say dictionary of int and int frequencies. And this next step, second step, is actually going to do quicksort. As I've mentioned, we're going to go down this path for this video, but also you can like solve it with different approaches. So and the way the quicksort is going to work is, once we construct these frequencies data structure, we're going to sort it by number like frequencies, right? And and the reason it is efficient is because we don't want to sort the whole thing. Like we don't need like this particular order. We don't need every element to be in their like exact spot. We just need to know, depending on how we sort. If we sort in like increasing order, we want the last k two elements, and if we are sorting in descending order, we want the first 2k elements. But the important part here is we don't need to sort the whole thing. We don't need every single element to be in the exact right spot in a sorted array or in a solid data structure. We just need them to be, we just need a delimiter or like a partitioner, which can say, okay, like the left part has k elements, and the rest is actually doesn't matter. After we discussed our overall approach, for dictionary, we can briefly touch on time complexity and space complexity. This is dictionary. Yep, this is actually a very important step, because all of those FAANG big tech companies, they really do care about performance, and that's definitely something on your interviewer's evaluation sheet, so you want to check that box. So for time complexity of this algorithm overall solution, what we will need to do is, first of all, we will need to go through every single element, and we can say n is number of elements in nums array. For every single element, we need to construct this dictionary. We need to go through every single element and put it in a dictionary, or at least like have a number of frequencies for it. So it's going to take all of n. And the interesting part, the trick here, is the quick select is not going to operate on all those elements, because like obviously we have a lot of duplicates here. It's going to operate on unique, we can say U is going to stand for unique. I think that's how you spell unique. Unique elements in nums array. So after that, we need to do quick select, but not on original nums, but on unique elements of that nums. So we can say of U. But a quick side note here: this is average time complexity. In a worst case scenario, it's going to take like U square time, because it really depends on how we choose our pivot. But that's like very specific case, but in general, like on average, your algorithm is going to run on a linear time. So this at the end just gives us O of n. The overall time complexity is still going to be affected by the every element in our list, and this is always going to be a subset of U is always going to be a subset of n. So we can safely assume it's going to be O of n, and I think we can put a note here. Worst case, it's going to take O of U square. So with that being covered, let's also discuss space complexity, right? So we need the dictionary. Dictionary going to hold every single element of that original array. So we're going to go ahead and say of n. Yep, and in worst case scenario, I think every element is gonna be present only once. So this dictionary might end up being like always might end up taking the exact same space as the original array. So this is the worst case scenario, and that should get us covered. All right, now we are ready to move to the next part. All right, so the next part is actually what everybody's been waiting for here is coding. So the first thing here is pay attention to how you name your variables, pay attention to how you name your functions. So let's say we have a function most k frequent elements, and let's say we are given nums. It's going to be an array of integers, and we are given k. It's going to be an integer, and in return we want to have an integer array. So with that being covered, let's actually go ahead and change the font of it so it does look like. Let's make the font a little smaller. All right, and maybe we can go ahead and remove make the spacing a little bit smaller so it does fit in the screen. So the first thing is, and that's why having an outline is very important. The first thing we want to do is to create our dictionary. Let's say we have a dictionary of frequencies, and it's going to be array of or dictionary of where the key is going to be an integer and a value are going to be an integer. And we want to iterate through our nums for I in nums, and for every element in here we go. For every element in our nums, we want to go ahead and say frequencies. Check if we have that element in our frequencies, and in case if we don't, let's default to 0 and increment it by 1. So what this code basically does is that it goes through every element. Let's have our example here and put it right here. Let's not forget to change the font. All right, so make the font smaller so it does not look odd. So we have this input right here, and with this step, what we want to do is actually create a dictionary where, like for I, we're going to have 1 is going to equal to 2, because that's now how many times we encounter 1 in this array, and then for 2 we're going to have 3, and for 3 we're going to have 4. All right, so with that being clarified, let's go to the next part. Let's go back to our outline. We said we're going to have a dictionary, so we got it covered. And next, let's use our QuickSelect. So for that, let's create another function. Let's just call it QuickSelect. And remember, guys, for those questions like QuickSelect, where you're going to use like QuickSelect, breadth first search, depth first search, Dijkstra, binary search, always have some template. Like your create your own template, your most favorite way to implement that algorithm, because let's see all those algorithms all the time from interview to interview. So you don't want to waste time trying to remember or like second guessing how you should implement each algorithm. You want to be like very fast with those steps. So I'm going to show you my way to implementing QuickSelect. For this example, let's define some input we're going to need. So we need to quick select sort this thing by frequencies. So we want frequencies, let's say, and we're not going to change it, so it can stay just that. We don't need in and out. And then what we want is some array that we're going to change, so that's why it's in and out of integers. So basically this is going to be the array we're going to sort, and then we just need our low and our high. That's going to be an integer as well, and in return we want to return an integer. So this is basically going to be a pivot we're going to use to sort our thing by. So let's jump straight into the implementation. For QuickSelect, the very important thing is to pick a right pivot. So let's say we have a pivot index come on, and it's going to equal to integer and in. So we're going to have from to high. Yeah, and then like the first thing we want to do is to put our pivot array swap at our pivot index with our high. So that way like our pivot is always going to be in the the last element. Let's have some example here. Let's say we have like an array, it can be in any order, this, but remember, yeah, we're gonna pass here arrays, it's gonna contain unique values, so let's keep it that way. And then, so here basically I'm gonna show you how the QuickSelect works. So yes, let's first implement it. So what we want here is, first let me create a left pointer, and it's going to start with low, and then for I in low till up to high, but not including, I'm gonna check if a frequency of an element array with index I is less or equal to frequency of element our pivot. So our pivot basically now is the last element. Remember, we swapped it, so I'm going to compare it with the pivot, and this is going to return me optional, so I'm going to force unwrap it, because I can be sure that each element is indeed in our dictionary. So if that is the case, I want to swap array swap at I, and I want to swap with left. Yep, and I want to increment my left plus 1. Let's have this function started in a new page. So yep, so this does the work, and then after that we want to do the last swap. Because we are going up to high but not including, we want to make a last swap with our left, and then we want to return left. So let me quickly explain what's going on here. So we are picking a random number, and we have our I, let's say here, and then we're going to have L here. So left is going to start from first, and then I is going to start from low, so we're going to start from index 0. And so let's say we picked, I don't know, what do you guys want to pick? Let's say we picked 5, actually 5, yeah, this element. So the first thing is we swap it with the last element, which is 2, so we put 5 here and 2 here, 2 here, and now our pivot is the last one. Now what we're going to do is compare. Let me quickly go through just like try to explain what's going on here. So basically I'm going to go through all the steps that we just coded, so you guys like you and me are on the same page. So we have our pointers, so this L stands for left, right? And let's say we have, this is the frequencies. What we want to do is go through every element. So let's say I pointing here, L pointing here. We compare if I is less than or equal to P. If it is the case, we're gonna swap I and left, right? So but I and left are pointing to the same way, so like nothing doesn't really happen here. So we just increment I and L, and this loop continues. We compare it back to our high. It is smaller, so we just increment it. And the interesting part happens again, like here it's all the same, so we just increment it. And then finally we have something that does not satisfy this case. In this case only I gets incremented, and then again like this, it doesn't fall into this if statement, so I just gets incremented, and then actually like it doesn't even get incremented, so this for loop stops. So at the end we want to do another swap, but just to clarify, let's throw in some extra number here. Let's say we have 4, another 4 here. It cannot be 4. Let's say we have 3. We didn't have 3, right? Yeah, we had 2, but we didn't have 3. So let's say we have 3. We're at this point. we are at this point. 7 is smaller or bigger than actually than p our pivot, which is high. We just increment I, and then like we are at this point. So 3 is actually smaller than 5, so we're gonna go inside this if statement, and we're gonna go ahead and swap 6 and 5. So, or 6 and 3, I should say here, right? 3. So this is, I think this better illustrates how this quick select is going to work. And then after that, this loop stops, and we finally wanted L gets incremented, right? So after the swap, L gets incremented, and we exit this for loop and want to do our one last swap, which is we want to put 5, our pointer here, and put L to the end element. So as element, the L pointed, right? But and then we want to return the L left pointer. So we're going to return this index of this element. So basically, this quick select let us achieve is that everything is going to be divided into parts. So we're going to have everything starting from the smallest element up until and including p at one side, and on the second side, on the right side of our array, we're going to have everything that is greater. Remember, that's why we have small or equal. We're going to have strictly greater than p. I'm going to say p plus 1 and up until the end. So I think that like clearly demonstrates the way that quick select is going to work. So that's why this particular algorithm, quick select, is very effective. Like you see that, for example, this part, this is the left part, right? So this part is not sorted, but every element on this left side is smaller than every element, strictly smaller than every element on the right side. So that's how we can quickly achieve of getting smallest, case smallest or biggest, greatest numbers in an array. So with that being said, let's go back to our main function and try to use this quick select. All right, we are back in our main function, most k frequent elements. Now we want to call our quick select. But the way we do it is actually, and yeah, before we call it, let me quickly create a var list of array that we're gonna use our frequencies keys to make that array. So for this example, the list is going to look like 1, 2, 3, and it can be in any order actually. So because dictionary doesn't guarantee any order, this is not sorted in any way. So yeah, with that being said, let's call our quick select. So the way we do it is create a var L, and we can start with 0. For R, we can go all the way till the last element. So the way we get the last element is list count -1, and then we say while L is strictly less than R, we're gonna do something. So what we want to do here is let's create a pivot point, and we're gonna call this quick select. And let's quickly glance through the declaration, right? So we need frequency, we need array, and low, high, and we return an index, right? So we're going to say quick select. We're going to feed it our frequencies. We're going to pass our list because it's in and out. We want to do a reference, and then for low we want to say L, and for high we want to say R. So now here's the tricky part. Actually, remember the way our quick sort works. Let's have this example. Let's say we have some array. Let's say it's 1, 2, 3, 4, 5, 6. I don't know. And so the way our quick select works is it's gonna put everything that is smaller or equal to pivot to one side, to the left side, and put everything that is strictly greater than our pivot to the right side, right? So it's kind of sorting in ascending order, but our question asks for most k frequent elements. So like imagine this is frequencies of elements, like it can be 0, 1, 2, 3, 4, 5, right? So for number 5, this is actually not the number but frequencies. So if we sort it in ascending order, what we want is the last k elements from that list, right? So the way we can achieve it is actually say if our list dot count minus pivot equal to k, we can go ahead and return array, and we're gonna say list, and remember, right, we want last 2 elements, for example, and then as we can say list dot count minus k elements, and all the way till the end, and that's it. Yeah, so this is going to return us as array slice, and we're going to convert it to array to match our function declaration, and going to return it. We want the same statement at the end of this. But this is not most frequent case. The chances are that we pick our pivot because we pick it randomly. The chances are that this case is going to match small. So we don't want to start with it. We want to start with like more general case. If list.count minus pivot is actually smaller than k, and then else if list.count minus pivot is greater than k. I think those cases, like those two cases, are going to happen much more often than this case. So we can just at the end we can say this, and we don't even need this if inside. So like this order matters because it's a small like tweak, but it shows that you care again about performance and stuff like that. So just side note there. So what is happening here is that again, like we want last two elements, and for that, like if the list count minus pivot is smaller than k, it means this part is actually smaller than what we need, and we want to search this left part to find a pivot somewhere here that going to divide this part in a way that pivot plus one element is going to match this k. So here we want to say that our r is actually going to be pivot minus one, and hence here we want to say pivot plus one. All right, but this is actually like very tricky part. It's easy to get wrong, but once you practice and once like you really understand what's going on here, you can come up with it during the interview. So yeah, with that being said, I think we're done here. So the next part, remember the framework, guys. And if you haven't watched that video, please take a moment, like after we finish here, take a moment and watch it. I'll have a link at the end of the video. But next part is very, very important. You want to do is dry run or test, in other words, test your code. Because I have been testing like my code, like because I was explaining you a lot of things in this video. I think most of it is covered, but what you want to do is like mimic during your interview, at least like maybe mimic the same style, or if you, but like again, you have to be mindful. It might take a lot of time, but again, you at least at the end you want to like quickly glance through your code and to catch some bugs and check for typos. Check your code at least, right? I think I have because I explained like how the QuickSelect works. I'm pretty sure it works in a way I intend it should work. So that should be covered. Yeah, I have a small typo here. This is a lowercase. It should be lowercase in and out, right? So this QuickSelect part is pretty much covered. The interesting part is like, and then again, like this one is explained here in code. Interesting part is happening here, especially yeah with this returning. Like I return last because the way my QuickSelect works, it is sorting in increasing ascending order, but I want most frequent elements, so I want last, not the first k elements, but the last k elements. So the way I do it is I take the count number of elements, subtract 2. So count here is 6. I subtract k is 2, right? So 6 minus 2 is 4. So I start with element and index 4. So that's how it works. I should have braces here. So that is covered. And the interesting part again happens here. Like how do I decide which part to shrink? Is again like having a picture here really helps. So for example, I'm like at this point this is how I divide. It means that my count minus pivot is actually greater than, so I'm going to get, if I subtract this part, I from the whole array I get this part, and if this part is actually greater than my k, it means I need to look in this part, right? So that's why I say L is going to equal to pivot plus 1, so basically this part. So that's why I change L, and obviously in the opposite case I need to be looking on the other side. So for R I have this part. So yes, with that being said, I think we are done here. All right, if you made it till this part, thank you guys. I just want to quickly show you that I have checked this code and it does solve the problem. It should be more than enough for you to pass your interview. So with that being said, thank you again for watching. Please like, subscribe, and comment. It is very important. I'll have some important links down in the description. Again, link to it to this Blind75 original post. I'll have a link again to my Blind75 tracker, and I'll be posting new videos soon. So stay tuned, subscribe, like, share, and thank you so much.